Hello everybody, I work for the Simon company and we're a provider of infrastructure cabling to many universities, but obviously on a global level to many big organisations, including the likes of HSBC and Barclays and UBS. So we're used to dealing with very big installations and very small installations. So one of the things that we're very proud of, and we do specifically for our end users, is we provide a design-based document for you to be able to issue out. We work with you to consult in what you need, and then we turn that document into a specification that's then fully compliant with all the latest standards. And as you probably saw from my little screen grab, I mean, I sit on 2 of the British standards. My colleagues around the world sit on most of the standards that are relevant. Because one of the things that tends to happen is you guys come up with a plan of what you want to do and how you're going to do it. And then that gets taken out of your hands and handed over to a contractor who's going to put in the cheapest, most basic system that he thinks is going to meet your needs. And it doesn't necessarily do that when you come to it. So you move into your new building, and then you're finding you're already having to add additional points and make these changes and everything else. So by being able to provide you with a document that then goes all the way forward through that specification, through the build, we're then able to help you make sure that that's happening. So we can come down and during the installation, and we'll come down and we'll carry out audits, and we'll make sure that it's been done the way that it needs to be done. So as I said, not everybody does this service, but it's something that Simon are particularly proud of, and we do it very efficiently. And as you can see, we've provided, that's just a couple of them on the bottom of the slide there, University of St Andrews and Cardiff and Bristol and Sussex Uni, and there's a lot of them just in your environment, and we do this for many of our clients as well. So that's a little feature about Simon. Now I'm going to talk to you about intelligent buildings. You've already heard about new voice applications and how they're working, and power over Ethernet. All of these things need a road to run on, and the cabling infrastructure is that road. And if you skimp on that road, then all your shiny new toys and all the things you want to work will not work properly. You'll have interference on the line, you'll have calls dropped, you'll have cameras that aren't quick enough, many things. So we see it as a vision that IP will all run over a single cabling infrastructure. So that means you're going to be able to power and control everything, PoE, PoE plus, remote powering when you jump above that. There's lots and lots of things that are developing on the cabling there. And if you look back at 5E, when 5E was ratified the second time in 2001, nobody had heard of power over Ethernet. Yeah, so all of that infrastructure, nobody had heard of it. And many people would, it's all right, it's only 120 meters, it will still work, we'll get where we want. Yeah, we'll just put that one there. And now they're trying to do all this fancy stuff and put in the PoE phones and everything else, and they're just not working. So we've got to follow a strict set of standards, because PoE, when it came, the base requirement was category 5E, or ISO 11801 Class D. So a lot of people had exceeded those parameters without knowing it, and now their systems aren't working. So we're trying to work with you guys and help you explain, and the standard's been written around all of this infrastructure and the designs and everything else. So we're working with you to make sure that you're getting what you need to do it. So if you do this, then your CapEx, because you're only running over a single infrastructure, and then your operational costs will come down as well. You're all very quiet. I'm not used to this. I'm not used to this. People I talk to are robust in their responses towards me. So normally, in a normal building infrastructure, you have many types of cabling that are running sound, door entry, alarm. Think of a system that's running there, and they all have different cable types, and all of those cable types need a different set of infrastructure rules to get there, different containment, different densities and everything else. So whilst we can pull all of those things and bolt them into the IP network, that's done on proprietary software, which doesn't make them work very well indeed. So our intelligent platforms are going to integrate and work over a single bit of cable. Just as a brief there, that's roughly what you've got out there now. You've got phones, CCTV, audio, access control, you can read it all up there. All of those different media types need a different type of installation. They need different containment, they have different rules on how far they can go, how far they can't go, what they can be next to and what they can't. So that's just a few. So if you think now you've got all of these types of cable, all of these are different contractors coming in to install them. So now your your provision of this is going to go up in cost. If you turn it all into IP, which you can do, you can then have them all linked to the IP network but still have all of that different types of media that they need to run on. But we see that an IP convergence will bring all of that onto a single RJ45 and then subsequently fibre backbone infrastructure to be able to fully deploy all of these systems over a common infrastructure. And once you have a common infrastructure, you have an easy way of deploying it, reduce labour costs because you're only getting in one type of contractor. You can reduce the cable pathway, so you're reducing the space you need in the ceiling, in the floor, in the walls, wherever they may be. You can reduce all of that and really bring down your costs. But this means that the infrastructure is now the fourth utility. You've got to have electricity, you've got to have gas, you've got to have, it becomes the fourth one. Because without the road for all this stuff to run on, your now critical building management services aren't able to run properly. If your air conditioning goes, that's no good. If the sound system goes, that's no good. You have to really look at the infrastructure as a proper facility that you need to maintain across your estates. So if it's then IP, it can be managed. If it can be managed, it can be monitored. And you can do a whole bunch of things. One of the things that you can do is see when a switch port was last used, because quite often we run out of switch ports as we're going. But if you can get in there on an IP system, you can see when there was something last connected to that device and possibly reclaim the port if it hasn't been used. So you can start to reduce the cost of your switches and everything else by being able to monitor it because it's IP. So the problem with all of this is that they all come under different people. They all come under facilities, estates, IT. Nobody owns all of those systems. So we need to look at it more holistically and make sure that we invite everybody to the table so they understand the features and benefits of going to the newer systems. The IT guys are resisting the facilities guys touching any of their stuff, and the facility guys are like, no, we'll keep it ours because that's our little empire. But if you take security cabling, for example, once you've put all the coaxial feeds of the cameras into the security room, that security room can never move because of the impact of change is so huge. If you bring it all onto the IP over a common infrastructure, moving the system or the control office is really easy, and it doesn't take too much to do as long as you've got provision at the other end to cope with the bandwidth of that cameras coming through. But it's on a common platform and it makes it very easy to do. So there's some of the things, not everything. You'll see a little thing in there probably that says fire. Now, fire alarms themselves, certainly in the UK, the sensors are all running on pyro cable. They cannot be changed. But the alarm box itself can be included into the IP network. Yeah, if the fire alarm goes off, okay, we want the fire brigade to come and put the fire out. That's a good thing. But other people might need to be told. And because you've created an IP event, you can do anything with that. You can do absolutely anything with that event. You can tell the MD, you can tell the head of estates, You can create a local call for send out all the people. You can do many, many things, and that can be then hooked into the door entry systems, and everything can go and be related. So the other one that can't as such is the alarm systems for security. Most insurance companies still insist on their own proprietary cabling, but again the box itself can be hooked into the network. Once the box is in the network, you've created an event. You can do many things with the event. So, power over Ethernet trends. You can read up there that it's a huge, huge business. There's hundreds of millions of ports of power over Ethernet, and there's confusion over to what power over Ethernet is. Because power over Ethernet covers the PoE 1 is 12.5 watts, and PoE 2, otherwise known as PoE plus, is 35.5 watts. Anything over and above that is not classified as PoE. We're coming into remote powering, and remote powering and PoE plus are really, really demanding on the RJ45 infrastructure that you have. You can see there that HD base T, which is TV stuff, is 100 watts. That's a huge amount of cable to be chucking down an RJ45. Sorry, huge amount of cable, huge amount of power to be going down a cable. Okay, and there are effects to all of this, is that the cables are getting a little bit warm. Yeah, and going to potentially move outside of their allowable operating range, which on the standards-based guidelines is -20 to +60. In the UK, we don't suffer from heat too much. Yeah, we're never really worried about what the temperature is. But if you go to places like Dubai and things like that, it will increase. So, but when we install our cables are typically not in the air-conditioned space. So with those cables not in an air-conditioned space, and we all like to see our cables neat and tidy, so we're going to bundle them together. And we have found through research that the cables are getting really warm. A PoE plus alone increased the cable temperature by 10 degrees C. And this is another one. The wireless networks, yeah, faster speeds all coming through. But all these access points need power to them. Yeah, and it's all PoE, or remote powering, so that we can get the access points where we need them without the electricity. But we have to provision the right type of infrastructure to make sure that this happens. So as you can see there, we need 2 cables now. So now we're putting more and more cables into our infrastructure. Our infrastructure is growing from 2 points per user, so anything that's not a user is coming under the building management side. So you've got your wireless access points, your door entry. All of this is increasing the volume of things that are coming onto our RJ45 infrastructure. So here's our heat rise considerations. As I said, specified operating range -20 to +60. If you go above 20 degrees C in cabling, you reduce your maximum reach. Data cabling is specified to reach 100 metres, with 90 metres of fixed infrastructure, 10 metres of stranded cable. That's what we're allowed to do. But there is a condition on that the temperature does not exceed 20 degrees C. If the temperature goes above 20 degrees C, then we have to put into the formula, which is written into the standards, and reduce the amount of... that's not 5 minutes. No. Yeah, I've only got 9 fingers, but I know that that's not 5 minutes. Yeah, so the infrastructure will reduce in its length because you have attenuation. So, and that's above 20 degrees C. Getting to 40 degrees C, and unshielded cables actually fall off quite a big cliff. And I'll show you some graphs in a minute. You'll see how much distance we lose. So now we're going to put power down it. I say PoE plus showed a 10-degree increase. So now we're up at 30 degrees. Go into some of the areas where they're behind the glass and everything else. The temperature's creeping up dangerously close to our maximums. So we've developed our product and changed our product to cope with this increasing need. So you can see here on the graph, the top one, the 6A UTP. This is standards-based stuff at the top. Yeah. UTP at 60 degrees, you can see the derating factor. This is blurred. Is it me? Is it blurred? It is, isn't it? Yeah. Yeah, we can see that the insertion loss derating factor as we go along there of how far down we've got to reduce the cable lengths. And this is for PoE. This isn't for the whether it passes 5E, 6A. This is for PoE. PoE is really limited to this 100 metres. If you go above the 100 metres, you get the voltage drop. So we need to over-specify the cables for our data rate to cope with the electricity that we're putting down with it, down the cable. So we've worked really, really hard to make sure that our product is there. All of our jacks on our 6A and our Terra, which is a unique thing, it's greatly helped with the PoE, because there's another issue with PoE, is that when we plug the device in, the device is asked if it can have electricity. If it says yes, then the power is supplied. But when we unplug it, and we unplug it under load, there is a risk of an arc. Yeah, on the laptop you can see a video as you extract the RJ45, yeah, as it breaks contact, we get an arc, and this arcing will degrade the material there that's keeping it sprung. So you take away its tensile strength as you do it. So you're reducing the amount of times that the contacts within the socket can be plugged and mated. So on a jack, for example, it's supposed to be able to do 750 cycles of mating and derating. That's to be standards compliant. We think that this is going to reduce it to something like 100 cycles, which isn't very many on your infrastructure. So again, CMON have made sure that our swipe bit, the seated position, is where you need the contact. So by being able to have the contact there, and then it drops down the contact and arcs at another place, is helping minimise the impact of this unplugging under load. In the standards meetings that I'm attending at the moment, they're looking at ways to implement something on the device so you can turn it off before you unplug it. Because at the moment there's nothing, you just unplug the device. Yeah, the only way you could do it is to go into it in software and turn it off at the switch. So they're looking at ways at the moment to implement that within the hardware to stop the power coming. So we really have worked hard on that. That's a repetition. So in order to cope with all this extra infrastructure, EN 50173 Part 6 has been developed very recently this year, in fact, and been released to change how we think about our infrastructure. Our typical infrastructure in other editions of the 50173 standard will talk about how to cope with the user, but this is how to cope with your now building management systems. And this is one of the ways we introduced the service distribution bit there, where what are we going to provide? The service outlet. So you can still have all the bits of your current cabling and they can coexist, but depending on how you use it, depends on what it gets called and then the rules that you can have around it. For example, if you're having a user, then a user has to have all 4 pairs terminated. But building management systems don't have to have that. Yeah, they can come out of the service provision and each pair can be shared out, which is where our Terra connector, and we're not alone, it's not totally proprietary, although we invented it, can really help reduce the extra infrastructure that you're going to need to cope with all of these extra devices that are coming on your network. Because if you think of how many wireless access points and how many door entries and everything else, your comms rooms and your cabinets where all this cable's got to be housed has to be increased. So the Terra solution can help minimise the impact of that as we're going forward. So changing the design on how you look at your infrastructure as well, because the impact of change is huge. You may not be coming to IP door entry today, but as eggs is eggs, in time these things will happen. If you've got a door entry system, eventually it will migrate. So putting in the infrastructure now and keeping it dormant is significantly cheaper than coming in and doing it retrospectively. So we're trying to go down a zone box there, deployment method. So a zone box can have up to 24 outlets and just be provisioned there. Some of it you'll use for your users, some of it you'll use already for your wireless access points, but predominantly they'll sit there until you need them. And we're trying to get this down to about a 12-metre squared diameter for each zone box, which sounds quite a lot, but it's not when you look at, we're thinking top, low level, high level, however we've got to provision for these additional things. Because when the change does happen, running a short lead from a zone box that's provisioned in this room is significantly easier than having to go all the way back to the comms room and lift the corridors up and get downtime in the comms room. Being able to do that just by plugging effectively an RJ45 extension lead in to our zone box is absolutely massive. So we can put the zone box anywhere. There's a big case study which we show you how to the actual operational and capex cost differences. I'm being chased to go. So the summary: applications will run over low voltage RJ45, flexible infrastructure due to zone cabling, capex and opex savings, PoE heat build-up managed by good product, and the physical connections protected design when unmating in a power environment, and we can help you. Any questions? See, you asked me if I could do it, I did it.
Yes, well done. That's excellent. Just one quick question for Tony, because I know everyone's going to be desperate for a cup of tea probably.
Well, I didn't, cause I'm puckered deaf, so I'll go through my translator.
You didn't mention lifts.
Lifts, you can't have cabling in lifts.
You didn't mention your infrastructure cabling on supporting it.
Yeah, because the infrastructure itself for the phones and things like that, they're connected at the top. The lift itself manages the infrastructure to a connection point, and that comes onto the IP telephony system the same as. Yeah.
That sounds like a good question for later on this morning, I think.
Okay.
I was wondering what the scrap value is of copper, because I've got lots now to pull out.
It's good. Copper is very expensive. Okay.
Right. Thanks, Tony. Can we thank Tony in the usual way?